Okay, so continuing, we have here the Otto cycle. So, Otto cycle naman po, usually it is used for internal combustion engine. Okay? Otto cycle po is the fundamental thermodynamic cycle used to describe the operation po of our spark ignition engine. Okay? Or commonly found po in gasoline-powered vehicles. Okay, so it is characterized by its focus on constant volume heat addition, which we'll be discussing later on, and rejection, making it a practical model for many internal combustion engines, which I have mentioned a while ago. Okay, so here is the PV diagram and the TS diagram. Okay, so this one is the PV diagram. And this one is the TS diagram. Right, so again, pagsabayin lang natin ang discussion ng PV diagram and the four processes in the Otto cycle. Okay, so kopyahin lang natin to dito sa TS diagram. So, lagi lang natin to yung mga heat added. So, that is from 2 to 3. Okay, 2 to 3. Kung nandito ito ang 2 to 3, ibig sabihin dito yung heat added. Then, syempre, dito yung heat rejected. So, 4 to 1. And then, 1 to 2, that is work input or yung compression. Then, dito yung work output. Okay, yan. Okay. So, Otto cycle. So, for our first process, okay, process 1 to 2. Process 1 to 2 is what we called the adiabatic compression process. Okay? So, in this case po, since yan ay adiabatic, okay, it can be also, by the way it can be also called isentropic. Okay, kapag adiabatic. Okay, isentropic. So, equal lang po yan, isentropic compression process. Okay, sulat na lang natin siya dito. Can also be written as that, It could be isentropic compression process. Okay? So, therefore po, pag adiabatic, there is no heat transfer. And entropy nga again is constant. Alright? So, in this case po, ang ating S1, okay, is simply equal to S2. Okay, though hindi naman masyadong gamitin dito ang entropy, but still, yun lang naman po yun. Okay? And then, ang atin pong ito palang 1 to 2. Dito, yan lang siya. Okay? And then, for process 2 to 3, this one is 2 to 3. And for process 2 to 3 naman po, that is constant volume heat addition process, or pwede rin po nating sabing isometric, also volumic isochoric heat addition. Okay, pwede rin pong isochoric, isovolumic, or isometric. Okay, either of the three pwede yan. Isochoric heat addition process, isovolumic heat addition process, isometric heat addition process. So, pwede po yan. Iba-iba. So, therefore, volume is constant. Okay? So, ibig sabihin po, ang ating volume 2, okay, ang volume 2 natin is equal to volume 3. Po tayo doon. Alright. Okay? Ayan. And then, we have here the adiabatic 3 to 4, process 3 to 4. Process 3 to 4. Process 3 to 4, we call this adiabatic, okay, or isentropic expansion process. Okay. Yan. So in that case po, we have 3 to 4. Expansion process, we have here. So same thing po, heat is 0 dito. And then, okay, so S3 equal to S4. Okay, and then lastly, we have here the process 4 to 1. Or what we call the constant volume heat rejection process, or again isochoric, isovolumic, isometric heat rejection process. Same lang naman po yun. So constant volume tayo. So in that case po, we have there the heat rejection process. So ibig sabihin meron tayo dong mako-compute na heat rejection po. Okay? No. So in that case po, alright, so yan po ang ating PV diagram at saka TS diagram ng Otto cycle. Okay? So we have here different formulas to be used. Okay po? Ng atin pong under Otto cycle. So mas madami siya compared with Carnot cycle. Okay? So this one po, alright, we have here, ayun, please take note that RK, or compression ratio, is equal to V1 over V2 is equal to V4 over V3. By the way, these equations po, okay, these equations are from the isentropic equations, okay, ng PVT relations. Okay, so isentropic, and yeah, isentropic. Okay, so we have here, ayan, in terms of compression ratio, in terms of compression ratio, pressure and pressure ratio, okay, where again itong mga RK na ito, okay, that RK is equal to this, and then syempre yung RP, okay, is equal to this, or the compression pressure ratio. Okay, so we also have heat added, heat rejected for work, cycle efficiency, and then compression ratio. Okay, and then we have your mean effective pressure and the maximum temperature. Okay, in this case po, ang ating pong maximum temperature, which is very obvious, okay, is the T3 po. Okay, T3 is the highest maximum, Tmax. Okay, while the lowest po is 1. Tama? Yeah. The minimum temperature. Okay? And then, ang pressure nga po, again, is yung P3 din. Okay? Based dito sa ating PV diagram. Okay? P3 is the maximum pressure. And then, yung P1 natin, okay, is the lowest pressure, or the minimum temperature. Pressure rather. Okay? So, ayun. So, again, for you to easier understand the equations, edi let's apply it in a problem. Okay, so let's try to answer this sample problem number 1. So, a gasoline engine operating an Otto cycle has a compression ratio, or RK, is equal to 8, and the specific heat ratio, K, 1.4. Calculate the thermal efficiency of the engine. So, first thing first, edi write down the given. Okay, so we have here compression ratio, so that is RK, 8, and then we have here the specific heat ratio na 1.4. Sabi dyan, find the thermal efficiency. Solution for efficiency. So for efficiency, since meron tayo dyang compression ratio at saka K, so pwede natin itong gamitin for efficiency. Okay po, obviously yun lang yun pwede natin gamitin. So 1 minus R, 1 over RK raised to K minus 1. So, substituting 1, RK natin is 8, ang ating K is 1.4 minus 1. Okay, so calculating the answer would be 0.564,724,7184 times 100%. So in that case po, ang ating efficiency ng engine is 56.4724,7184 degrees Celsius. Okay po tayo doon? Question so far? Okay, I guess none. So, number 2. An ideal gasoline engine operates an Otto cycle with a compression ratio of RK is equal to 10. Temperatures at the beginning of the compression and after heat addition are T1 is equal to 300 Kelvin and T3 which is equal to 1500 respectively. The specific heat ratio of air is 1.4. Calculate A, the thermal efficiency of the engine, and B, temperature at the end of compression. Okay, so first thing first, the given muna po. Okay, and then we have here, ang given natin dito ay compression ratio 10. Meron din tayo ditong T1 na 300 K or Kelvin. Meron din tayo ditong T3 which is 15 Kelvin. Okay, so find A is thermal efficiency and B is T2. Solution. For A, we have here efficiency. So same thing efficiency natin since meron tayo ditong RK, ayun, kailan po tayo, K is equal to 1.4. So yung N natin, okay, pwede nating yung efficiency natin rather, pwede nating kunin gamit yung kanina nating equation na ginamit na N is equal to 1 over RK raised to K minus 1. Okay, so substituting, we have here RK na RK na 10, 1.4 minus 1, 1. Okay, so the answer for this is, kindly confirm, 0.60189,28294. So multiplying by 100%. Therefore, ang ating efficiency is 60.189,28294%. Okay, did you yield the same answer? Question so far? And then for T2, we have here, pwede natin kunin dito is yung, since meron tayong given na T1, T3 at saka compression ratio. So from here, pwede natin makuha ito in terms of compression ratio. Okay, pwede natin kunin ang T2 using this equation. Okay, so that case po, T2 over T1 is equal to V1 over V2. Tama ba? Okay, K minus 1. Again, where V1 over V2 is simply equal to RK. Therefore, T2 over T1 is equal to RK raised to K minus 1. So, pwede nating sabihin na T2 is equal to T1 RK raised to K minus 1. Substituting, we have here T1 at 300 Kelvin. Okay, and then we have here compression ratio na 10. And then we have here K minus 1. Which is 1.4 minus 1. Tama? 10, 1.4. Okay. Therefore, ang atin pong T2, Calculating 300k times 10 raised to 1.4 minus 1. The answer is 750, ano to? 53. 569. 5659. 565929 Kelvin. Okay. Alright, so ayun po. That is for auto cycle. Do you have questions? May tanong po kayo with regards to the problem? Okay, I guess none. Alright, so let me end this lecture.